Prader-Willi syndrome is a genetic disorder that, in infancy, causes poor feeding and low muscle tone, and then in childhood causes overeating, intellectual disability, and low sex hormones. Prader-Willi syndrome happens when a handful of genes on chromosome 15 aren't transcribed into messenger RNA and therefore aren't expressed. Among these are SNRPN, which stands for small nuclear ribonucleoprotein polypeptide N, and a cluster of SNORNAs, which stands for small nucleolar RNAs. And these genes all have protein products that modify other RNAs. Now, normally the copies of the genes contributed by the mother, or maternally derived genes, to this region are silenced or turned off, and only the genes from dad, or paternally derived genes, get expressed. This special genetic process is called imprinting, where only one copy of the gene gets expressed, not both. And this differs from most genes in the genome, where both the maternal and the paternal copies are expressed. So those maternal copies are imprinted and therefore silenced. And this silencing of the maternal copies is an epigenetic process. In the word epigenetic, epi means outside of, and genetic refers to the DNA sequences of A's, C's, G's, and T's. So epigenetic silencing of a gene means turning it off while keeping the DNA sequence itself the same. The Prader-Willi genes get turned off when methyl groups get attached to the DNA, a process that happens way back when the mother was making an egg. Even after fertilization of the egg and all of the cell divisions it takes to make a person, the epigenetic mark remains, kind of like a reminder to keep those maternally derived copies of the genes turned off. Unfortunately, though, this means that if paternal copies of the genes don't get expressed, then there aren't any backup copies being expressed, and so no copies of the genes get expressed. And this is exactly what happens in Prader-Willi syndrome. Now, there are a few ways these paternal genes wouldn't be expressed. The most common one is a deletion on the paternal gene spanning the Prader-Willi region. A lot of deletions also include a nearby gene called OCA2, which codes for a pigment that gives color to the eyes, the hair, and the skin. So Prader-Willi patients with deletions that encompass OCA2 can have a light complexion. Now, a second way is called maternal uniparental disomy, which means two chromosomes from one parent, the mother. If both copies of chromosome 15 were derived from the mother, that means all the Prader-Willi genes are methylated and therefore silenced, since there aren't any unsilenced paternal genes. This can happen when the primary oocyte in the female, which eventually becomes an egg cell, undergoes non-disjunction during meiosis I, which ultimately results in an egg cell with two maternal chromosomes. And after combining with a sperm cell, you get a zygote with 3 copies, called trisomy 15. Since trisomy 15 isn't compatible with life, the fetus only survives if they lose one copy of the chromosome in the early embryo, called trisomy rescue. So if it's the paternal chromosome 15 that's lost, the result is maternal uniparental disomy 15. Alright, a third way to get Prader-Willi syndrome is a mutation in the imprinting center, which is a sequence of DNA near the Prader-Willi genes that directs imprinting via sex-specific methylation. If that paternal imprinting center gets mutated, then that region gets methylated, and those genes get turned off, meaning that both the maternal and the paternal genes get silenced. Sometimes, though, that methylation happens on the paternal chromosome even when there's no imprinting center defect, and that's called an epimutation. Normally, the paternal grandmother's methylation, after being passed to the father, would be erased when the father's making sperm. But in epimutations, it doesn't get erased, and so it gets passed on. Finally, there might be translocation, which is when 2 chromosomes swap material. Translocations can disrupt snRNP and move the small nucleolar RNA genes away from their imprinting center, causing them to get methylated and turned off. Usually, newborns with Prader-Willi syndrome have low muscle tone, which makes them extremely floppy. They also have a poor sucking reflex, which makes it hard for them to take milk, and can have failure to thrive, which means that they have poor weight gain. By late infancy, eating gets better, but then turns into overeating because the child feels hungry even with a full stomach, which is a problem caused by dysfunction of the hypothalamus. Without restricting access to food, a child with Prader-Willi syndrome can become morbidly obese, which can lead to other conditions like type 2 diabetes and obstructive sleep apnea. As a result of the mutation, children often have distinct physical features, like almond-shaped eyes, a narrow forehead, and a thin upper lip, as well as small hands and feet. They can also have developmental delay and a low IQ. In Prader-Willi syndrome, the hypothalamus has issues secreting gonadotropin-releasing hormone and growth hormone-releasing hormone, which can cause decreased sex hormone levels and short stature, respectively. Now, with Prader-Willi syndrome, there's a mutation in the Prader-Willi gene region on the paternal chromosome. One thing to be aware of, though, is that a mutation to the same region of genes on the maternal chromosome can affect a gene called UBE3A, which is only expressed on the maternal chromosome and imprinted on the paternal chromosome. If this happens, it causes Angelman syndrome, which results in severe intellectual disability, seizures, and ataxia. This region, therefore, is more accurately called the Prader-Willi Angelman region, because paternal mutations lead to Prader-Willi syndrome, and maternal mutations lead to Angelman syndrome. Diagnosis of Prader-Willi is done by looking for evidence of a genetic mutation linked to Prader-Willi. And as for treatment or management, it's often necessary to restrict the amount of food that a child with Prader-Willi eats. And this is often done by locking the refrigerator and cupboards. In addition, giving growth hormone can help improve overall height and lean body mass. Unfortunately, though, there's no medicine or surgery that's worked to control the overeating. Alright, as a quick recap, Prader-Willi syndrome is an imprinting disorder, where mutations only on the paternal copy of chromosome 15 causes the disease. In infancy, it causes low muscle tone and poor feeding. And then in childhood, it causes overeating, obesity, inadequate genital development, and low IQ.